Good morning, class. Now in this video, we will try to think about some methods to prepare a salt. Now to prepare a salt, we need to find a suitable chemical reaction. We need to consider the lab safety issue and also to know that whether the reagent is available in the laboratory or not. In addition to the chemical equations, we also need to think about the separation method, whether we can obtain the salt from the reaction mixture very easily, and also to consider what kinds of impurities that may be present in the reaction mixture. To find a suitable reaction to prepare a salt, we need to consider the properties of the products. For example, whether it is soluble or insoluble in water. Now here, I have three balanced chemical equations, which may be used to produce lead 2 sulfate, which is an insoluble salt. In equation A and B, I have lead 2 hydroxide, which is an amphoteric hydroxide. Now you may need to check what is the meaning of amphoteric. Now in equation A, the reactant lead 2 hydroxide and calcium sulfate are insoluble in water. Now in fact, we seldom have reaction involve solid reactants. It is very difficult for solid reactant to react. Now so if you put lead 2 hydroxide solid and then mix it with calcium sulfate solid, there won't be any reaction. And then in equation B, we also use amphoteric hydroxide and then add sulfuric acid to it. Now, but in the second equation, the reactant and lead 2 sulfate, the products, are insoluble in water. Even though if there is chemical reaction to produce a small amount of lead 2 sulfate, we have a great difficulty to separate the lead 2 sulfate from lead 2 hydroxide. It is impossible for us to obtain the product in good yield and in good purity. So equation B is not a good method, although we have the balanced chemical equation. Now in equation C, two salt solutions are mixed together. Will there be any reaction just mixing the two salt solutions? Now it is because the lead ion and sulfate ion produced from the dissociate of this salt will combine to form the solid lead 2 sulfate, and the sodium ion and nitrate ion remains dissolved in the solutions. Now so it is very easy for us to obtain the white precipitate by filtration. And this is the possible method for us to prepare lead 2 sulfate. Now besides using lead 2 nitrate and sodium sulfate, can you think about other combinations of reagent that can be used to prepare this product? So you can discuss this with your teacher during the online lesson. Now, so in conclusion, if you want to prepare an insoluble salt, you can select a soluble reagent that contains the respective cation and a soluble reagent contains the anion, and then mix them together. And we don't need to care about whether it is an acid-alkali reaction or any reaction that you have learned before. We just do this by precipitation. Now I have some example here. Now would you please use a few seconds to think about the reagent required to produce the salt listed in this table. Now for the first compound, barium sulfate, we need to think of a reagent that contains the barium ion, but it must be soluble in water. So what barium compound must be soluble in water? Now in our solubility table, we know that all nitrates are soluble, so we can choose barium nitrate solution and then mix it with another reagent that contains the sulfate ion. We also know that all group 1 sulfate are soluble in water. So if we mix barium nitrate with sodium sulfate solution, and then we have the white precipitate, which is barium sulfate, and your solution contains NaNO3. Besides sodium sulfate, can we have other source of sulfate ion? Now in the second reaction, in the second salt, it is iron 2 sulfide. Now when you were in Form 3, you know that when iron powder is heated with sulfur powder, the compound, a brown solid iron 2 sulfide, will be formed. And there is another way for us to make iron 2 sulfide from the solution. The reagent that contain iron 2, very easy, we can use iron 2 nitrate. And how about the sulfide? Now in this compound, sulfide is S2 minus. So all group 1 compounds are soluble. Then we can use sodium sulfide. And then in the last example, we have copper 2 carbonate. So you need to find the source of copper 2 ion and the source of carbonate ion. Now we can use group 1 carbonate, which is soluble in water. Now may I take this opportunity to remind you, because many of the students use carbonic acid as a source of carbonate ion, now which is not acceptable. Now do you still remember in the previous slide that we need to consider whether the reactant is available or not? Carbonic acid is not available in ChemLab. We cannot have a supplier to sell carbonic acid to us. So we should use sodium carbonate. And would you please avoid using carbonic acid in answering the questions? After selecting the suitable reagent, we mix the solution together and obtain the products, the insoluble salts, by filtration, and we keep the residues and then dispose the solution. We need to wash the residues with small amounts of deionized water because, for example, in the first salt, barium sulfate, there are some sodium nitrate remains in the solution, and so maybe the surface of the white precipitate will be contaminated by the sodium nitrate. So we need to wash the solid with a small amount of deionized water, and then we need to dry the insoluble salt in air or in desiccator or in oven. Now if you propose to dry the salt in a hot oven, you have to think about whether the salt is stable at high temperature or not. After that, then we can obtain the mass of the products. And do you still remember what is meant by percentage yield? And we can also calculate the percentage yield of the chemical reaction. Now what should we do if we need to prepare a soluble salt? Then we cannot use precipitation. Precipitation is used to make an insoluble salt. To make soluble salt, we use neutralization reaction or acid metal reaction or acid carbonate reaction. In all these reactions, we have the salt solution formed, and then we want to obtain the salt crystals from the solution, so we need to use crystallization. And what will be the proper procedure for carrying out crystallization? Now let us look at the chemical reaction first. Now because we need acid, so acid is the soluble reagent. And then the base, the metal, or the insoluble carbonate, they are the insoluble reagent, but must be in excess amount. Now, so if we want to prepare zinc chloride, which is soluble in water, by looking at the possible reagents, we can use the acid, which is hydrochloric acid, and the metal, so we can dissolve zinc in hydrochloric acid, and your product is zinc chloride and hydrogen gas. Or we use the acid and the base, the metal oxide, so we add zinc oxide to hydrochloric acid. Your product is zinc chloride solution and water. And then in the third method, we choose the acid, hydrochloric acid, and we add with the carbonate, zinc carbonate, to form zinc chloride, carbon dioxide, and water. Now in the three cases, the insoluble reactant must be in excess amount. So we need to add excess zinc into hydrochloric acid, and then when the gas bubble stops and we have some solid zinc left in the solution, that means all the hydrochloric acid has been consumed, and then we can remove the zinc metal, obtain the solution, which is the zinc chloride solution, and then perform crystallization. Now the same as zinc oxide and zinc carbonate, the insoluble reagent must be in excess amount. Now to further explain this method, I want to show you a past examination question, which is the 2012 practice paper. This practice paper was given out by HKEAA for the first cohort of students. Now in this question, it asks you to prepare hydrated zinc sulfate. Now you see the term hydrated. That means you have water of crystallization, and the zinc sulfate should be obtained from crystallization. Now in the experimental method, you need to warm sulfuric acid and then add zinc oxide in excess. Now, so do you still remember our method? We have the soluble reagent and an insoluble reagent. The insoluble oxide must be in excess amount. The zinc oxide will dissolve in sulfuric acid until we see that some left behind solid. That means the sulfuric acid has been completely reacted. And then filter the reaction mixture. When we are filtering the mixture, what is the residues and what is the filtrate? We need to keep the filtrate and heat the filtrate until it becomes saturated. Cool it down and leave it at room temperature until the zinc sulfate crystals comes out. We have to separate the crystal from the solution, wash them, and dry the crystals. Now for question A1, write chemical equation, which is very easy. In A2, how do you know that zinc oxide is in excess? So I have just told you. And then in A3, explain why zinc oxide rather than sulfuric acid is used in excess. Now this is very important. So would you please think about this at home and discuss this with your class teacher later. Now in step 3, it says that you need to heat the filtrate until it becomes saturated. But how do you know? How do you know that you have already obtained a saturated solution? Now think about this at home and discuss this with your class teacher. Now I have found some information from Google that if you want to get a saturated solution, you add small amounts of solute to the solution if the new solute does not dissolve. Now, is it just copying what you got from Google to answer part B? And in part C, we need to wash the crystal with small amounts of water. Why? How to dry the crystal? Dry it in air, in desiccator, or can we use the oven to dry the crystal? And then the last question, suggest one chemical to replace zinc oxide. If we do not have zinc oxide in the laboratory, what should we do? Now, before ending this video, you need to, number one, check what is an amphoteric hydroxide, and also suggest the reagent to prepare lead 2 sulfate besides what I have suggested to you. And also check how to calculate the percentage yield. And of course, you need to think about question A3, B, question C, D, and E.